In this video we have the integral of dx over pi x plus 9. We want to evaluate this. This is a really basic U-substitution problem here. Let me give you the general look here. Anytime you have something like dx over ax plus b, now you could have a constant here, say another k. A and b here, of course, are constants. X is the variable. So I could have a constant here, no big deal. I just bring it out here and then work it out, and then the constant k multiplies whatever I get. But notice if I let u equal to ax plus b, remember again that a and b are constants, then du would equal to the derivative of what I have on the right. Derivative of a constant here is b is 0. For this one, because it's multiplied by x, this would just be a. And then this would be dx. So then this would equal to dx then divide by a with du over a. So I can replace this dx by du over a. So it would be du, and because a is a constant, I could just write it over here as 1 over a. And then this, of course, is the u. And we have a general formula for the integral of du over u. That's 1 over a. And for this formula here, it's just ln of absolute value of u. But I always have to go back to the original variable, so instead of the u here, I just put ax plus b, and then plus the constant of integration. And that actually gives you a formula whenever you have something of this form, where in the numerator we have just dx, or it could be a number. Now if it's an x, it's going to be different, but if it's a constant over here, then it's always going to be this format here. Like I said, if this had a constant k here, then you'd have the k over the this constant a. So this is the same problem. Pi is just a constant. Derivative of a constant is 0 when it's by itself. So I could just do this one using that formula then. This is just going to be ln absolute value of pi x plus 9 plus the constant of integration. In this case, this would be the a that I had here in this formula. So this would be 1 over pi, and that would be your integral. But if you want to show all the steps for the instructor, then we could do the same sort of thing. U equals to pi x plus 9, and du would equal to, this is just the same thing if this were 2x. The derivative would be 2. So the derivative in this case, pi is a constant. This would be pi. Derivative of a constant by itself is 0. And then this would be your dx here. And then dividing by pi, dx would equal to du over pi. And then we go ahead and transform this into an integral involving the variable u instead of x. So it's the integral for the dx, replace it by du over pi, and I just factor out that constant 1 over pi, and then the denominator is the u, and then I just use the general formula for the integral of du over u. So this is going to be ln of absolute value of u, but I know I have to go back to the original variable. So instead of putting a u there, I just put pi x plus 9. This 1 over pi, and that is plus the constant of integration. So notice if this pi were a 7 instead of pi, then I would just have a 7 right here, 1 over 7. And if I had a 3 up here, then I'd have a 3 over here in the numerator. But that's the integral for this problem here. Thanks for watching. We'll see you next time.